Pluto's hidden mystery. For decades, Pluto has remained a world shrouded in mystery. A lonely outpost at the edge of our solar system, frozen, forgotten, barely touched by sunlight. In 2015, NASA's New Horizons spacecraft flew past it, and the world gasped. For the first time, we saw its glaciers, jagged mountains, and a shimmering, tenuous atmosphere. But something in that data didn't make sense. Pluto's atmosphere was far colder than models predicted. Scientists expected around 73 degrees Celsius, yet measurements were over 30 degrees colder. Not a small error. A cosmic anomaly. Something was cooling Pluto in ways science couldn't explain. For nearly a decade, the mystery remained unsolved. Until the James Webb Space Telescope, humanity's most powerful eye in space, turned its gaze toward Pluto. The truth it revealed was far stranger than anyone could have imagined. Back in 2015, scientists expected a barren world. Instead, they found towering mountains of water ice and smooth plains of frozen nitrogen stretching for hundreds of kilometers. Above this alien landscape hovered something unexpected, a thin bluish haze, wrapping the planet like silk. It wasn't dense, but it reached nearly 300 kilometers high, far taller than anyone thought possible for a world so small. It shimmered in sunlight, forming delicate glowing bands across the sky. But the most baffling part wasn't its beauty, it was its temperature. The atmosphere was freezing far beyond what nitrogen and methane alone could explain. For years, scientists ran models, recalibrated sensors, rechecked data, yet the math refused to add up. Something invisible was stealing heat from Pluto's skies, and no one knew what. Then, in 2017, planetary scientist Shi Jiang from UC Santa Cruz proposed a radical idea. What if Pluto's haze wasn't just dust or ice? What if it was alive, in a chemical sense, actively regulating the planet's climate? According to Jiang, tiny particles floating in the upper atmosphere could absorb ultraviolet light from the distant sun. And instead of warming Pluto, they could radiate energy away as mid-infrared heat, cooling the atmosphere far more efficiently than gases alone. Pluto's haze, he suggested, might be acting like a massive thermal shield. Most scientists dismissed the idea as impossible. Particles controlling planetary temperature? It went against everything known about planetary physics. But Jiang's theory made a bold prediction. Pluto's haze would emit a faint, distinct mid-infrared glow. And only one instrument in existence could detect it, the James Webb Space Telescope's MIRI instrument. In May 2023, it finally happened. An international team led by Tanguy Bertrand pointed Webb at Pluto and its moon Charon. For the first time, scientists separated the faint heat signatures of the two worlds, something no previous telescope could do. Using MIRI, they scanned Pluto across multiple infrared wavelengths, 15, 18, 21, and 25 microns. The results were staggering. Pluto's infrared glow was far stronger than expected, too strong to come from its frozen surface alone. Something above it was radiating extra heat into space. When the team isolated Pluto's atmosphere, the results were undeniable. The haze wasn't just scattering sunlight. It was glowing, radiating infrared heat like a cosmic exhale. NASA had found the missing energy. The haze was not a byproduct. Pluto's discovery rewrote planetary science. For decades, scientists believed gases controlled climate, from carbon dioxide warming Venus to methane shaping Titan. But on Pluto, solid particles, microscopic tar-like compounds called tholins, were running the show. Tholins form when ultraviolet light hits methane, triggering a cascade of chemical reactions. These reactions create complex hydrocarbons that drift downward, layer by layer, forming Pluto's haze. and the haze glows in infrared, cooling the atmosphere from above. The planet itself functions like a massive chemical engine. Haze forms, radiates, and collapses with each orbit. Even more astonishing, methane from Pluto's atmosphere escapes into space and lands on Charon. There, sunlight transforms it into reddish organic compounds at the Moon's poles. In other words, Pluto is literally painting its moon. Webb's data hinted at something deeper. This haze-driven cooling might not be unique to Pluto. Titan, Saturn's largest moon, also glowed in the same mid-infrared wavelengths. Titan and Pluto became mirror worlds, both frozen, hazy, and governed by chemistry that seemed almost alive. Even Neptune's moon Triton, once thought geologically dead, showed faint atmospheric heat signatures. These distant icy worlds weren't silent, they were active. Their skies were talking to each other across the cold reaches of space. Webb's spectroscopy revealed that tholins are far more complex than imagined. Chains of hydrocarbons, some containing nitrogen and oxygen, the very elements found in amino acids, danced across Pluto's skies. On Earth, similar reactions may have sparked life billions of years ago. Pluto's haze wasn't just cooling its atmosphere, it was cooking chemistry on a planetary scale. Even stranger, the haze pulsed rhythmically. Its emissions matched Pluto's 6.4-day rotation period almost perfectly. The haze wasn't random, it responded to the planet's daylight rhythm, synchronized to the pulse of sunlight itself. Physics, chemistry, and something more began to blur. Scientists began comparing Pluto's mechanism to exoplanets orbiting dim red dwarfs. Worlds like K218b and TOY 700d showed faint mid-infrared dips identical to Pluto's spectral lines. These planets were larger and warmer, yet their atmospheres behaved the same way, radiating away excess energy, stabilizing themselves. Such stability could mean habitability in ways we never imagined. Pluto might not be an anomaly. It might be a prototype, a blueprint for habitable chemistry in the cold, dark reaches of space. But the discoveries didn't stop there. When Webb observed Pluto's night side, scientists expected silence. Instead, they found faint, rhythmic light, structured, precise, and repeating every 247 seconds. At first, it seemed like reflected sunlight from Charon. The geometry didn't fit. The pulses weren't random, they were signals. Each pulse contained mathematical sequences, the golden ratio, pi, Euler's number. It wasn't noise. It was intelligence. NASA officially labeled it instrumental interference and buried the report. But independent researchers who reprocessed the data found the pulses originated beneath Pluto's surface. Webb detected weak electromagnetic echoes reflecting off a layer 12 kilometers below the ice. It wasn't rock. It wasn't water. It was metallic, vast, and nearly a third of Pluto's diameter, perfectly spherical. Pluto, long thought geologically dead, was alive in ways we couldn't have imagined. Faint rhythmic tremors synchronized with the infrared pulses. The planet wasn't just cold, it was transmitting, communicating through a cosmic code. One researcher whispered in disbelief. It's like the planet is trying to speak. The signal continues to echo through the void. Sometimes it grows stronger, sometimes it fades, always repeating the same mathematical sequence. The question is no longer what Pluto is, but who, or what, placed it there. If this story makes you question what we truly know about the outer solar system, don't look away. The James Webb Telescope is watching, and the universe might just